Imagine spending hours preparing a welding project, carefully measuring every cut, setting up your workspace, and getting everything ready, only to realize halfway through that you chose the wrong welding method. The welds aren't holding the way you expected, production is slower than planned, cleanup takes forever, and suddenly what should have been a simple project becomes a frustrating headache. Here's the truth. Many welders don't struggle because they lack skill. They struggle because they use the wrong welding process for the job. When it comes to welding, selecting the right method is just as important as selecting the right machine. It's like trying to drive a race car through a muddy construction site or using a hammer when you need a precision screwdriver. The tool matters, but the application matters even more. Among the most popular welding processes in the world today, two methods continue to dominate workshops, fabrication plants, construction sites, repair garages, farms, and manufacturing facilities: MIG welding and stick welding. Both are incredibly capable. Both can produce strong welds. Both have built industries and careers. But which one is actually better? The answer might surprise you, because the strongest, fastest, or cheapest option isn't always the right choice. In today's video, we're diving deep into MIG versus stick welding. We'll explore how each process works, their advantages and disadvantages, where each one shines, how modern technology has transformed both methods, maintenance costs, productivity differences, and ultimately help you decide which welding process best fits your needs. By the end of this video, you'll know exactly when to choose MIG, when to choose stick, and how professional welders make that decision every single day. Let's get started. What is MIG welding? MIG welding, short for Metal Inert Gas Welding, is one of the most widely used welding processes in modern manufacturing and fabrication. The process uses a continuously fed wire electrode that comes from a spool inside the welding machine. When the welder pulls the trigger, the wire automatically feeds through the welding gun while electrical current flows through it. As the wire reaches the workpiece, an electric arc forms. This arc generates intense heat that melts both the wire electrode and the base metal. The molten metals combine and solidify into a strong weld joint. At the same time, a shielding gas surrounds the weld area. This gas protects the molten weld pool from oxygen, moisture, and contaminants in the atmosphere. Without this shielding gas, the weld could become weak, porous, and structurally compromised. One reason MIG welding has become so popular is its simplicity. Most MIG machines require only a few primary adjustments: voltage, wire feed speed, polarity. Once these settings are dialed in, welding becomes a relatively straightforward process. This simplicity explains why MIG welding is often the first process beginners learn. How modern technology has revolutionized MIG welding. MIG welding today is far more advanced than it was even a decade ago. Modern inverter-based MIG welders now feature digital control panels, synergic welding controls, auto parameter adjustment, auto arc stabilization, pulse MIG technology, Bluetooth connectivity, and cloud-based welding data tracking. Some industrial welding systems can automatically adjust voltage and wire speed in real time based on material thickness. Advanced robotic MIG welding systems now dominate automotive manufacturing. In fact, modern vehicle production lines rely heavily on robotic MIG welding because of its speed, consistency, and precision. Artificial intelligence is also beginning to influence welding operations. Smart welding systems can monitor weld quality, detect defects, and optimize settings automatically. This level of automation was unimaginable just a few decades ago. Advantages of MIG welding. Let's talk about why so many professionals prefer MIG welding. 1. Extremely fast welding speed. One great strength of MIG is productivity. Because the wire feeds continuously, there is no need to stop and replace electrodes. This allows welders to complete jobs much faster than many other welding methods. In high production environments, speed means money, and MIG welding delivers. Excellent for thin metals. MIG welding provides outstanding control on thinner materials. It can easily weld metals as thin as 24-gauge sheet metal. This makes it ideal for automotive body repair, sheet metal fabrication, HVAC systems, and decorative metalwork. Clean weld appearance.
MIG welds are known for their smooth, attractive finish. Since shielding gas protects the weld pool, very little slag forms. That means less grinding, less cleanup, and a more professional appearance.
4. Easy to learn. Many new welders can produce acceptable welds after only a short training period. The process is intuitive and forgiving. This makes MIG welding one of the most beginner-friendly welding methods available. 5. High precision. MIG welding provides excellent control for detailed fabrication work. When appearance matters, MIG often becomes the preferred choice. Disadvantages of MIG welding. Despite its popularity, MIG welding isn't perfect. 1. Wind is the enemy. The shielding gas can easily be blown away by even a moderate breeze. When this happens, contaminants enter the weld pool. The result? Weak, porous welds. This is why MIG welding performs best indoors or in controlled environments. 2. Surface preparation is critical. Rust, paint, oil, grease, dirt. MIG welding dislikes all of them. The material typically requires thorough cleaning before welding begins. Skipping preparation can seriously reduce weld quality. 3. Equipment cost. MIG machines generally cost more than stick welders. Additionally, operators must purchase shielding gas, regulators, gas cylinders, contact tips, and nozzles. These expenses add up over time. What is stick welding? Stick welding, also known as shielded metal arc welding or SMAW, is one of the oldest and most trusted welding processes in existence. Instead of continuously feeding wire from a spool, stick welding uses a consumable electrode known as a welding rod. The rod is coated in a special flux material. When the electrode touches the workpiece and creates an arc, intense heat melts both the rod and the base metal. The molten metal combines to form the weld. Meanwhile, the flux coating performs two important jobs. First, it creates a protective gas shield. Second, it forms a layer of slag over the weld. This protective layer shields the weld from contamination while it cools. Unlike MIG welding, stick welding does not require an external shielding gas cylinder. Everything needed for protection is built directly into the electrode. That's one reason stick welding remains incredibly popular worldwide. How technology has improved stick welding. Many people think stick welding is outdated. That couldn't be further from the truth. Modern stick welders have evolved dramatically. Today's inverter-based stick welders offer hot start technology, arc force control, anti-stick functions, digital displays, portable lightweight designs, and battery-powered operation. Some modern units weigh less than 15 pounds while producing professional quality welds. Field welders can now carry powerful stick welding systems into remote locations where traditional equipment would be impossible to transport. Advanced electrode coatings have also improved arc stability, penetration, and weld quality. Even after nearly a century, stick welding continues to evolve. Advantages of stick welding. 1. Works almost anywhere. This is where stick welding shines. Wind has very little effect on the process. Rainy conditions, construction sites, outdoor repairs, remote locations. Stick welding handles them all. 2. Welds dirty metal. Rust, paint, corrosion? Stick welding can often weld directly through contaminants that would cause MIG welding problems. This makes it extremely valuable for maintenance and repair work. 3. Lower equipment costs. Stick welding systems are usually more affordable. There is no need for gas cylinders, regulators, or flow meters. This significantly reduces startup costs. 4. Excellent for thick metals. Heavy structural steel is where stick welding really excels. Its deep penetration allows strong welds on thick materials. Construction and infrastructure industries depend heavily on this capability. 5. Highly portable. A stick welding setup can often be carried directly to the job site. This flexibility is invaluable for field work. Disadvantages of stick welding. 1. Slower productivity. Every time an electrode is consumed, work stops.
the rod must be replaced. This reduces productivity compared to MIG welding. 2. More cleanup. After welding, slag must be chipped away. Additional grinding is often required. Cleanup takes time. 3. Greater skill requirement. Although beginners can learn stick welding relatively quickly, mastering it requires practice. Maintaining a consistent arc length takes experience. 4. Not ideal for thin metals. Thin sheet metal can easily burn through under stick welding's intense heat. That's why it isn't commonly used for automotive bodywork.
MIG versus stick welding, the ultimate comparison. Now, let's compare them directly. Round 1. Ease of learning. Winner, MIG welding. The automatic wire feed system makes MIG significantly easier for beginners. Most new welders achieve good results faster. Round 2. Speed and productivity. Winner, MIG welding. Continuous wire feeding means fewer interruptions. Production shops favor MIG because time equals profit. Round 3. Outdoor performance. Winner, stick welding. Wind and weather have minimal impact. Stick dominates construction sites and field repairs. Round 4. Dirty metal capability. Winner, stick welding. Rust and paint rarely stop stick welding. MIG generally requires cleaner surfaces. Round 5. Weld appearance. Winner, MIG welding. MIG welds are typically cleaner and more aesthetically pleasing. Less cleanup means a more polished finish. Round 6. Thick metal performance. Winner, stick welding. Deep penetration makes stick ideal for heavy steel fabrication. Round 7. Thin metal performance. Winner, MIG welding. Precise heat control helps prevent burn-through. Round 8. Portability. Winner, stick welding. No gas cylinder, less equipment, greater mobility. Maintenance and cost comparison. Many beginners focus only on machine price. Professionals understand the bigger picture. Operating costs matter. MIG welding requires shielding gas, contact tips, wire spools, nozzles, and regulators. Stick welding requires electrodes. That's it. However, labor costs can tell a different story. Because MIG welding is faster, businesses often save money on labor despite higher equipment costs. Large fabrication facilities frequently choose MIG because increased productivity offsets operating expenses. Stick welding may cost less initially, but slower production can increase overall project costs. The smartest choice depends on the type of work being performed. Which welding method should you choose? Choose MIG welding if you work indoors, speed matters, appearance matters, you weld thin metals, you are a beginner, you perform production welding. Choose stick welding if you work outdoors, you weld thick steel, you repair farm equipment, you need portability, you frequently weld rusty materials, you want lower equipment costs. The best welders don't argue about which process is superior. They understand that every welding method has a purpose. The real skill lies in knowing which one to use and when. Conclusion. So, MIG or stick welding, which one wins? The truth is, there is no universal winner. MIG welding dominates when speed, precision, and appearance matter most. Stick welding shines when durability, portability, and outdoor performance are required. Modern technology continues to improve both processes through smarter controls, advanced inverter systems, automation, robotics, and AI-assisted welding solutions. As industries move toward Industry 4.0 and intelligent manufacturing, both MIG and stick welding remain essential tools in the modern welder's arsenal. The most successful welders aren't loyal to one process. They're adaptable. They understand the strengths and weaknesses of each method and choose the right tool for the job. And that's what separates an average welder from a true professional. If you're just starting your welding journey, understanding this single comparison can save you countless hours, reduce frustration, improve weld quality, and help you make smarter decisions on every project you tackle. The next time you stand in front of a welding machine, you'll know exactly which process belongs in your hands, and that confidence